Hi everyone, welcome to Query Execution Plan Explained video. So in this video we are going to talk about how a query is executed and how we can improve the performance of a query in SQL Server. So what I am going to do here, I am creating two sample tables. One is customer and customer order. I also have an index customer ID created in this customer order tab. I have populated the data. This is straightforward. Like we have our Alice, Bob, and Charlie here, right? And in this customer order, what I'm going to do, I'm going to create around 1 lakh records. So how I'm going to create? I'm randomly populating those records by using a basic concept. Like I have a table called SPT values in master, and I'm doing a cross join. It has around I think 2000 or some that main record. I'm doing a cross join, and I'm not taking any column from that. Okay, so if you go into like I'm using row number and all these functionality to populate around uh, 1 lakh records the way I want. So I'm creating a customer order with a row number like order ID as 123, and here I'm using only because I have only 3 customers, right? I'm creating a random IDs like 321321 like that, so that like I can map each order based on that like each customer. And I have order date. Then what do I have? Order date. I'm finding a date. So this like yeah, and I'm populating a random number here as it is order sorry order amount and product ID. Okay, so that is pretty much. So what I am going to do, I'm populating these two tables. So our primary goal is not to populate this data, right? So I just want you to understand how it works. So we are closing this table creation. Okay, don't need to save it. So now we just wanted to test this query, is it performing well or not. So before that, I'll show you. I have new database created, ESA learning. If you go to table, I have these two tables, customer order. It has a primary key. Yes, sir, I think need a second, let me refresh it. Yeah, I have a customer order index and I also have a primary key. So if you take customers table, does it have an index? It has a primary key index, right? So now we have a requirement to combine this and identify the total spend for this customer. So we are joining this customer order and customer ID and grouping it. So I'm executing this code. I have also enabled the statistics on. So this is okay. Why this is so okay? I'm using a wrong database. I should use DSL. Yeah, don't get confused with this two, right? The shortcut is Control KC. So I'm enabling this execution plan which you're seeing here, right? Include actual execution plan. So we also have something called estimated execution plan. Estimated execution plan help you to give you an execution plan probably SQL Server would execute. Okay, if you click this here, so you can start seeing a plan. So this might be the plan which SQL might use. If it is a very large data set which you are going to do this activity, you can probably use estimated execution plan to understand what might be the probability. Okay, so here we can use actual execution plan, and we also have called something called live query statistics. So that is introduced in SQL 2016 and 2016. So this live statistics would help you to see this. So here you have this include actual plan, right? This populate after your query is completed. But if you wanted to see that what is happening as a live, right, you can use the live execution plan. Okay, so in our case our data set is very small, we only have 1 lakh record. I'm using include execution plan and I'm running this query. I have something called execution plan populated. Before we dive into, yeah, so we'll show you what is statistics on. Since I have already kept statistics on, so that is why you have seen these messages, but however I'll run this query once again. Have this execute. So this statistics on will help you to understand how much time CPU took, and so every stage of it, right? There is parsing, execution, compiling, all these steps are there. You would be able to understand where it took. Okay, there are 6 logical reads you can see. So this is something which you can understand, but we have a graphical representation to start with. Okay, so we will use execution plan to understand what happened. So in my LinkedIn post, I have mentioned couple of items like index, key, scan, and everything. So we'll start about that first. So we can see this is a single query which took 100% of your total time, right? So we are doing a cost based analysis. That means like how much like cost you took 1 second of 1 second to execute this query, what percentage of time each portion of a query took. So that is how we would analyze and improve that area. Imagine, right, you have 100 percentage, you have one area which took 90 percentage. So if you improve that area up into 50 percentage, you will directly get around 50 percentage of benefit in your total query. So that is how we will optimize our code. Okay, so here I have my execution plan. You need to start reading this execution plan always from this right side, not from here. So this is the last operation. So what it is saying, I have an index seek on my customer table. Customer table is very small table with just 3 columns. It took 0 percentage of your code, right? So that is not a big deal. That's totally fine to start with, right? It is 0 percentage. It does not impact much. So first we will see we have some indexes. Is it properly used or not? That's the first thing which we look at. Then we'll go deep dive and see like what are the things which we can do on improving the data. So I can see something called clustered index scan, that is saying it took 42 percentage of my time. And I also have a hash match that is telling me that it took around 50 percentage of your time. So this both itself taking your around 100 percentage of the time, right? So if you can do some operations and improve this, it will help you, right? It will help you to improve your code. So I can see index scan. So what is index seek and what is index scan? So index seek is like this is the operation which directly go and pick your data using the index hierarchy. So we use by B tree structure that help you to like go and directly into the particular node and get your data. So index seek, this is fine. So scan means it is same as table scan. It refers the index, but it is going through every record in this index to get your data. So this is not an efficient method, right? So that is indirectly telling us that okay, Samit, you may have an index, but that is still scanning. So there are two cases there might scan happen. One case is you do not have a proper index. Second case, you are retrieving almost around 80 percentage of data, rather than scan like seek and doing everything. Scan might be faster. There might be scenarios like that. So here let us see why this is taking scan. So you have only the customer ID, and we also have this customer ID as our index, right? So then what could be the reason it is taking scan? Because here the reason for scan is you are retrieving the entire data, right? Because however you are joining, you are retrieving the whole data to get your result. You really don't have a filtration, you are getting entire data. So that might be the reason you are having this scan. So let us apply a filter on top of this code and see what happens. Yeah, I have added a straightforward where condition on this data, and I said, okay, I don't need this entire data to be pulled. I only need the data where the order date is like last 3 months, right? Greater than current date, right? Last 3 months. Okay, so let us run this code and see what it gives. So we go to execution plan. Execution plan started showing you some missing index error, or like it's not an error, it's a warning that helping you to tell that, okay, if you create this index which SQL is telling, it can improve your performance 61 percentage. That means if it is taking like 1 second, you can get the query in around 40 second, like 0.4 second. Maybe if it is taking 10 second, you can get this query in 4 seconds. So that is how this index would work, right? Because here everything might look same. You have the same seek, you have the same scan, because however you are scanning and you are applying that filter on top of that. So this is not an efficient method, right? Now let me, so you can right click here, you can use missing index details. So it will open this code. So let me move this, and it itself is giving you the syntax to be ran, and all you need to give is like, you need to give an index name. So I'm getting that customer orders order date, right? So I'm telling, okay, I'll create. So let us understand what this index is, right? So this is a non-clustered index because you already have a clustered index, and it is using customer order date. You can see they have order date here because you have an order date as a filter, right? You also have something called include. So what is this include? So we covered in our indexes class. These type of indexes are called covering index. So if you don't have this include and you are still referring your customer ID and order amount in your data, right? So those cases you would be like, however you have this non-clustered index, you need to reach to clustered index. The activity is called lookup to get your entire result. But by having this include in your non-clustered index leaf node, that means the lowest level of your node, system would store the customer ID and order amount as well, so that like you can skip that lookup activity in your execution plan. That is going to save your time. That is why this system is telling. So if you want, what I can do as a first step, I'll comment this. I'm going to run this. So I think we don't need all these. Don't make it complicated, right? So this is your normal SQL query. So I'm running this again. So execution plan is telling, so you can see it is taking still clustered index scan. However, where is my code? However, I created this index. SQL is still taking clustered index scan, right? So why that is so? The reason is simple. So however you know that this filter work, SQL believe that, okay, going and finding that just using order date and coming back and doing the lookup on this main table is more time consuming than scanning this major table. So that is why SQL took a decision by eliminating your, because however this is a scenario where you might feel that, okay, I have my right index in the system, but SQL is still not taking the index which you have created or which already have, right? And I have an order date index. SQL should have directly taken my order date index, like order date index, rather than still taking your index scan. So the reason is based on the cost. SQL believes that, okay, now first filtering and again scanning this data would take me more time than doing the scan. SQL take analysis based on referring the statistics and all the information which it is available for it, right? So how do we like now let us create our index. So I'll create an index called 1. I'll include. So keep this in mind. You shouldn't be creating so many indexes, but I need this index for a purpose. That's why I'm creating this way. But however, you need to see, okay, what is the proper index which is needed. You should only be creating those indexes. Okay, you shouldn't be using all this mixing index, because this index this comes everywhere. Like whenever you run a query that does not have a proper index, you might get this recommendation. But what you need to think, when you have an index, you are going to increase the insertion time, right? Based on your DML operation, you need to see, okay, does it really make sense of having multiple tables, like multiple indexes? And also you need to see, okay, is there a way which I can rewrite my query that might help you to reuse any of these existing indexes, right? So we'll go into that. Now I have created this index and running this. Now like things have changed, right? Things have changed drastically, and you can see where is our table. So it started using customer order started using index seek. What is that index it is using? It is using customer order date 1, because that is where it is having the column being included, and that is taking 31%. You might feel that, okay, it is not drastically changed, right? When you consider this 31%, you wouldn't be able to calculate that way. How you can calculate is like how much time it really took earlier and how much time it is taking, right? And this is a small change where it is smaller data, where you may not be able to see very huge number like 10 second to 1 second kind of changes. So here I have this seek, and it is coming to loop, because the reason why it is nested loop, the other table is smaller, so having the loop would be faster. Then seek these things, right? So we have this aggregation happening, so aggregation is taking time, and this is based on data. There is nothing which we could do on indexing, and the only area where we can do something on top of the data is mainly on indexing and rewriting the query. These are the two areas which we can do something. One is make sure that you have a proper index. Second thing, you have this code written efficiently to make use of the code. So in order to understand how efficient your code is, you have to understand some of these basic functionalities. Let me see. Execution plan, right? So how a query get executed? There is something called an order of execution. How a query get executed? So first, very fundamental, forgetting about all this what we have talked, the way which you can improve the query is only read what you need. That means like you may have 1 million record, but if you need only 10 record, you take that 10, right? That like the traffic will be less and you will get less data. And definitely I'm not going to cover the design level optimization today. We have to learn about query level today. Okay, so first let us learn how this query getting executed and what is the order of execution. So the very first thing SQL goes, when you have your query written, it goes to from and see, okay, what are the table, like how I am going to read the data from where. It's from tables, views, joins, right? So this is your first execution. Second thing is where. That means like the filtering would happen as a second activity. And third is group by, having, then select, order by limit. So if you think that, okay, I'm doing top 10, will this improve my performance? So that is what I am telling here. This is the very last operation which you are doing. So all this operation, your like 1 million record will be there, and when you limit it, it will reduce, only show that record. So if you wanted to limit your data before doing any operation, where is the method? and before where we have from, right? So can we limit the data before it being used in, right? So that is where you have to think about cities, derived tables and all these things to limit the data and make use of the indexes efficiently. So keep this order in mind: from, where, group by, having, select. So here the major filters are like where and having. So having, the very first one which we can use is where. That's going to help you to limit the data the way you want. So let us see how we can rewrite this code which we have written, right? So what we have learned is like where condition would happen. First thing is from. So if you, when you look at this query, this is going to join with the entire data, right? So here I am using CTE. So what CTE does, CTE limit that data first. Before it apply that to the join, it filter the data to the 3 months and then join that result into it, right? So CTE is a recursive function, but this can also be used, this kind of functionality. I'll teach you what are the other way which we can accomplish this. So you can also put this into a table and do it. But here I'm filtering the data, right? First I am filtering, then joining. So however your from is your first activity. So before the from, this filter would happen. So anything joining, it is only joining with the 3 months of data, right? So let us see, run this code. So you won't see much changes in the execution plan because it is still using the same indexes. But think like you have some cases where your index is not supporting with multiple conditions. You have like 2-3 conditions in the where which you don't have an index, but you have an index for order date. You might be able to make use of this functionality, right? Or you think, so the best way to write is like filter and join, so that like you are only dealing with the data which is filtered. That definitely give you the benefit of the lesser data being combined. Okay, yeah, we can also write the same query, something called derived table. Same way, instead of creating this CTE, you can write that code inside the join, right? The same inside the join, and you can use. So here always the inner query execute first. Okay, so the same way. So here let us compare these two queries cost. So I'm going to run this. I have this execution plan on. I'm running both the code, and I'll come. So it gives the same result because same query, only that instead of CT I'm making use of that code inside a derived table, right? So if you see, execution plan is showing 50%. So what is this Go is really helping, right? So this is also helping you to like divide these queries into 2 parts, and you can also see this execution plan divided into 50% of this, 50% here. So that means total 100% of this total execution time, 50% is consumed by this. So if I do this, right, I'll comment this part just for learning purpose. Then I would run this code once again. You can see the first query is 21% and second one is definitely 79%. So what we can understand here, if you think both are same query, you did it in 2 different way, the 21% query is taking lesser time, right? On the total 100% of the cost, the first query took only 21% of the cost. So that means the first query is efficient than second. So if you are doing a comparison between 2 queries which you have written in different level, one with sub query and the other one with the direct join or filter, efficiently checking, right? You would be able to use this method, run both the queries and check the cost. So lower the cost, higher the performance. Okay. So here in our case, if you use derived table or CTE, it is taking same time. So you can, like, whichever is convenient for you, you can use it. I always use derived table so that like you will still see only single query. It doesn't look that complicated. Okay. So now we'll talk about something like you wanted to use the index which you want, right? Earlier we had a scenario, we created an index, but SQL didn't use that, right? So we have something called query hints. Okay, so if you use this query hint, right, with IDS, customer order, order rate, however, you have different indexes, SQL would still prefer to use a index which you told, right? So here, in like we have order one as an index, but we are telling the system to use order date because we believe that order date might be better. So I'm running this code. Does specified from the scores does not exist. I think this does not have a score. Okay, let me check that. Yeah, that was wrong. I was using the old one which I created. So now I'm using, I have changed to our order date one. I'm running this code once again. We'll see the execution plan. Here you can see, come all the way right. So you can see it has used customer orders, customer orders order date, which was using order date 1 earlier, but it started using the index we recommended or we told SQL to use. So this is called hint, where like a query hint, where you can decide which index should be used in your query. So this is not recommended because we believe that SQL optimizer or this execution engine is better to take better decision than us. But however, we can let the system knows that okay, this is we think that the best index. So here what happened, yes, it took the index, and since the order date is the column, it was very optimal. It took only 1 second. But here you can see there is something called key lookup, which is which took another 90% of your time. So what key lookup is doing, key lookup here you filter the order date, but you need customer ID and order amount, which is not available in your order date index, right? That was not a covered index, that had only order date as a column. So now you got to go to the major the main primary table to get the customer ID and order date, right? So that is what this key lookup does. So when you don't have, when you see a key lookup, keep in mind, you however you have an index, the index does not have all the columns which is required for you to complete the statement, like that whatever the column which you have in the select may not be there in your index index leaf node. That is why system has to do a key lookup. So when you see a key lookup, just include those columns not in index but in the include statement as to bring it as a cover index. So and when you create cover index, it always consume your space. So make sure that you are not overloading SQL with all the non-clustered index being covering index. You got to see what is the cost. So we have to always think about what is the cost of including this here, right? In reading perspective as well as in the writing perspective and storage. So when you keep adding this non-clustered index on a table, it is going to create another page. So we'll also be talking about the internals in detail. So this pages, so it will keep creating the pages when you create an non-clustered index. So we need to keep writing the data every time we do an insert. So you got to take a decision, do we really need to do that or not? Yeah, so I would conclude this video just by talking about statistics for a minute. So how SQL runs a query, right? We have learned about order of execution, from where. So how SQL decide which index is better, right? So that is where statistics comes into picture, right? Statistics and like previous execution history, all these things are like whenever you run an execution, SQL store this data, right? So what is statistics? Whenever you create an index, right, you can see on the left side you have also something called statistics created for the same indexes. So I have like I would take one of this order date, yeah, order date one which we created, and let me run this what it gives, right? IDX customer order date is not there, it is there, right? Yeah. So here statistics store very high level information, right? Okay, what data it contains and what is the range of it. It's kind of a histogram internally, but here I don't take much time. We'll talk about statistics and other query internal details in a different video, since this video is going too long than which I expected. So this statistics would help you SQL to take a decision. Like it is saying, okay, in your date of March 18, you have around 294 rows on the same date, right? But on 20th, you have 306 rows, and in that range you have 250. So these columns are like helping SQL to take a decision on, okay, so can I take this index or the other index, or like, okay, how, like rather than seeking, scanning would work. So I talked about the density, selectivity, and all these things, right? So those we would be talking in detail in upcoming videos. But keep in mind, SQL use your previous execution plan and the statistics to choose the right index to be taken, right execution plan to be built for your code. And there is something called, if the data is already there, we will use logical read, otherwise physical read. Those things are also there, but this is just a hint for you to understand statistics is something would help you to choose the right index. So if your statistics is not up to date, you may have the right index, you may have this data properly populated, but if you don't have a right statistics, your query can still go wrong and using a wrong index to get your data. So that there you can update your statistics to optimize your queries. Okay, hope this is clear. Understand that how like query execution works, how indexing work. Please start practicing, and SQL would take a different decisions than what you expected in cases. So you can understand that by a deep dive into how query optimizer work. Yeah, thank you for watching this video. We'll coming with the next video talking more about statistics, selectivity, density, and all these terms in detail. Thank you.